So we're supposed to find the solution of 3x squared plus 2x plus 5. Where does it cross the x-axis? I think it's probably good to get a visual first, so I type this in my calculator. 3x squared plus 2x plus 5. And I can see the question is, when does this red parabola cross the x-axis? By the fundamental theorem of algebra, it does have two solutions. But because it's way up here, we know that those solutions are going to be imaginary. So if you extended this x-axis, you would see that they do have two solutions that are imaginary. So I can't just get it from the graph. So what I'm going to use now is something called the quadratic formula. And that says if you have ax squared plus bx plus c, and you have it set equal to 0, you just plug in this formula and it'll tell you the solution. So I have in this form, it looks just like this form, so I know that this is going to be my a. So everywhere I see an a, I'm going to put a 3 there. So I'm going to put a 3 here. 2 is my b. So everywhere I see a b, I'm going to put a 2. So I'm going to put a 2 here. I'm going to put a 2 there and a 2 there. And then c is my 5. So this is my c. So everywhere I see a c, I'm going to put right there. And I realized I forgot my a. I also have an a down here. So right now, I know that this is my a, this is my b, and that's my c. So a is 3, so everywhere I see an a, I'm going to put a 3. So I'm going to put a 3 here, and a 3 here. B is 2, so I'm going to put a 2 here and a 2 here. And then C is 5. There's only one spot for the C, and it's right there. From there, I'm going to start simplifying. This makes this negative. And that exactly doesn't make it negative, it negates it. So if this is negative and you have another negative, it makes it positive, but it negates it. So that changes from a positive 2 to a negative 2. Plus or minus is how we get our two solutions. And I'm going to figure out what all of this is. 2 squared is 4. 4 times 3 is 12. 12 times 5 is 60. 4 minus 60 is negative 56. Now, if you're not good with computations, feel free to use a calculator. So what is 2 squared minus 4 times 3 times 5? That is negative 56. And then simplifying some more, 2 times 3. Hopefully you don't need a calculator for that one. 2 times 3 is 6. Now from there, I need to reduce square root of negative 56. Square root of negative 1 is I. So you could take out the negative and make that an I. So now we have I times square root of 56. And then you play around with 56, and you're trying to find pairs, because this is like an imaginary 2. 56, trying to think of two numbers that multiply to 56. I know 8 and 7 do. 7 is prime, so 7 doesn't break down into anything worth writing down besides 7 and 1. 8, though, is 4 times 2. And then 4 is 2 times 2. And what you're looking for is you're looking for pairs of numbers. I have 2, 2, 2, 7. So 1, 2 comes out from this group. And then these, the 2 and the 7, you multiply those because they don't have pairs, and they stay inside. So all of that, I would get I. 1, 2 came out. And then we had 2 and the 7 stay inside. 2 times 7 is 14. So I could replace this part with square root of 14 with the 2i. So I'm replacing this part. The rest stays the same. I have x equals -2 plus and minus all over 6. And then from there you should look to see, can I reduce any more? And so you're looking, is there a number that goes into -2, 2, and 6? And if there is, divide it all by that number. They're all divisible by 2. So I'm going to take -2 divided by 2, and I get -1. So x equals -1. 2 divided by 2 is 1, so I get 1i. And this is an 14, and that's an I. I know it looks kind of funny. And then 6 divided by 2 is 3. So there's my two solutions, -1 plus 1i squared root of 14 over 3, and -1 minus 1i squared root of 14 divided by 3.